Alright, what up everybody? This is Mr. Stan coming at you with another physics video. This time we're talking about convex lenses. Convex lenses look like the lens that you see right here on the screen where it's skinny at the top and bottom but gets fat in the middle. I'm here to demonstrate how light is bent and affected by convex lenses is Sir Roach. And we're going to use him to look at the ray tracing and see where the image is and what happens to the image when light goes through a convex lens. So there are three rays that are useful to draw. The first ray is one that starts parallel to the axis, and when it gets to the lens, it's going to bend such that on the other side it goes through the focal point. Okay, so you just connect those two dots right there, and you just continue drawing it. And that will give you the ray number one. The second type of ray that's useful is one that goes through the very center of the lens. And why is that useful? Because if it goes through the very center of the lens, then there will be, it will not bend between this part and this part here. And actually, it bends a little bit in the lens, but the bends cancel each other out so that you could draw a straight line through the middle of the lens, and that is where the ray would go. Ray number three goes first through the focal point. Then when it gets to the lens, it becomes a parallel line on the other side. Right? So it's kind of opposite of the first one. So just to review, first one is parallel at first, then goes through the focal point after it bends. The second one goes straight through the middle of the lens and doesn't bend at all. And then the third one goes through the focal point first and then is parallel on the other side. So to find his image, we only need two of those three rays. So we'll start with the parallel one. And the line is parallel first. It bends and goes through the first, goes through the focal point. Then we can choose one other one, and I'll go ahead and choose ray 3. And ray 3 first goes through the focal point, then becomes parallel on the other side. And you see where they cross right here. That is where the top of his head is going to be. Okay, and the bottom of his feet will be on the axis. So just like that. Right, so immediately what do we notice about his image? It's upside down, it's a little bit smaller, and it is real. Okay, why is it real? Because there's real light rays that are come together at this point, right? Neither of these light rays are virtual. Okay, so let's move him forward a little bit. So now he's in between the 2F and the F. In other words, he's in between the focal length and twice the focal length. The first ray is parallel, goes through the lens and bends towards the focal point. And the second one goes through the focal point, and then when it touches the mirror, it bends so that it's parallel. So where these two lines cross, that's where the top of his head is going to be. And so you can see that he's upside down. He's actually larger now than his object, right? So if he's looking at through the lens, someone's looking at through the lens at him, he looks taller than he really is. But he would be upside down. And this would be a real image. And the reason this real image is these are actual rays of light that are coming together to form this. Okay, finally, we're going to bring him inside of the focal length. And the first light ray is parallel at first and bends toward the focal point. And we'll do the second one that goes straight through the middle. And we're just going to trace that backwards to get the virtual ray. Okay. And somebody on this side of the lens looking through this it would appear that the light was coming from back here. That's what virtual means. So these virtual lines cross at the very top left, which means you get a large image. This image is upright and it's virtual, okay, because There are no actual light rays going from this object to the observer. Okay, so let's review what happened with the convex lenses. He started out here. His image was a little bit smaller and upside down. And as he moved inward, his image stayed out here, but it got larger, right? Um, until after he, this is his object right here. So after he gets inside the focal length, right? This is really him. Then his image looks like this. Looks really big. All right, so that's how convex lenses work, and I'll see you all in the next video.